In this section, we'll be looking at reading data from CSV files. I think this is a pretty useful skill to have in real Spark life and probably also when working with Ethan. Let's dive in. Here's Ethan. Surprise, you got an email from Ethan. The subject is Sustainability Project Data Preview. Oh, nice, we're getting some data. Hello, welcome to the team. I'm very happy that you will help us get started with our sustainability project. Thiago told me that you would appreciate having some data to play with. Attached, I'm sending you 2 files with some data we gathered for the project. We will be dealing with data about transport routes from manufacturers to our shops. I'm going to tell you more when we meet next week. Nice. Expect an invite in a separate email. So we're already going to meet Ethan. I hope you're enjoying your first week so far. Yeah, I am. Kind regards, Ethan. Attachments, routes preview, CSV, routes previews.json. Perfect. Now you have some data to practice on. Just as Thiago said, data seems to come from many different sources. Yep. CSV files, JSON files. Let's practice reading in CSV files with the routes preview CSV file. Spark offers fine-grained configuration for reading CSV files. This detailed configuration is necessary because although CSV files are somehow standardized, their format can differ slightly. You know this if you've ever worked with Excel. Sometimes there are like semicolons in there and they're hard to read in. So this is where Spark offers many different configuration options. Spark offers options, for example, skip certain lines at the beginning of the file or use custom separators. Here's the relevant documentation, and first we will use the DataFrameReader to read in the routes preview CSV file. How do you do this with the DataFrameReader? We just read in Spark Parquet files before. How do we do this? Let's first define a data frame where we want to read this in. This one is going to be called routes, and we say spark.read. Not Parquet. It's a CSV file, so we say CSV. And then we need to point it to this directory, so /file store /tables /routes _ preview.csv. And let's display it right away. Display routes. New data. Yeah, so the column titles are in the first row. This is not what we wanted, but we see distance, distance unit, bundle size, month, year, store ID. Okay, so some kind of route. But we can see that the column titles were not parsed correctly. Can you spot the correct option to fix this in the documentation for DataFrameReader.csv? Feel free to explore on your end. Pause the video for a second and try to find this. If you don't want to look it up now, then hold the line. There is an option here. It's called header. So let's try to use this option. Routes equals spark.read.csv and then /file store /tables /routes preview.csv header equals true. This is this new option. Forgot to display it. The most important part. Of course, we want to see that now the headers are in the right spot. And column titles. Yes, they are. SKU, store ID, year, month, way, distance. It's all here. Beautiful. And once again, there are different ways to express to Spark how the CSV file should be read in. And this is already a couple more ways than we had with the Parquet files, but let's go through them. So you can pass in options as this with this options command here. Before you finally call .csv, you can also use the load command, which we already practiced earlier when we are looking to read in Parquet files. And then you pass format CSV. The default is Parquet, so now you always have to pass format in. Header equals true. Okay, use the Spark load command specifying the format, but specifying the header option separately. So you have options here, and then you say, instead of CSV, you say load, and then you have to pass in the format equals CSV argument here. Use the load command and specify the header option in it, so here, but specify the format separately. So you also have the spark.read.format command that you can use. Here we use it again, and we don't specify the header option here, but we specified as the separate options command. So as you can see, now we're at 5 different ways. All of them work. So keep that in mind when practicing and when looking at code here that you see online. Having read in routes preview as a data frame, let's have a look at the schema Spark chose for routes. Okay, let's look at it. What's the schema? SKU is a string, store ID is a string, year is a string, month is a string, way is a string, distance is everything is a string. Okay, and if you look at the data itself, it shouldn't be a string. I mean, year should be an integer, store ID, well, maybe a string, but certainly not with this 0.0 here. SKU, okay, well, maybe that's a string. I haven't seen all the SKUs. In practice, you would have to ask Ethan a little bit more for information about what the schema is supposed to be like, so you can work with it and hopefully also validate it. Then there's distance. Yeah, this is definitely a number. So not so happy with the schema here. And you can see Spark chose string type for all columns. Do you think this is appropriate? Of course not. Let's see what the first couple of lines of routes preview.csv look like below. So here, once again, I make use of DB utils. This is not relevant for the exam, but we just do this so we can see the first couple of rows here of routes preview. Okay, you see already, sometimes it says 0.0. Like this looks 2017.0. We know this is the year, but it looks like a floating point number. Yet Spark parsed it as a string. So I'm not so happy with the choice here. The all string schema, which Spark chose for routes, does not seem appropriate given the data. Passing infer schema equals true to the DataFrameReader tells Spark to guess the schema. Let's try that. So read in routes preview CSV as a data frame and have Spark guess the schema via infer schema equals true. So let's do this. Routes equals spark.read.csv. Then we need the file path, which was /file store /tables /routes preview.csv. Yes, we want the header. And now we want to ask Spark to please infer the schema by just looking at the data. And we want to display the result. Path does not exist. Where's my error? Aha. Not review, preview. Here we go. Visually, no difference for starters, but let's look at the schema. SKU long. Store ID double. Okay, makes sense. Year double. Month double. Way is a string. Yep, that makes sense. Distance double, and so on and so forth. So you see, it already looks much better. But you may already see that some fields have not been assigned the correct type. Let's imagine parts of the SKU mapped to different product categories. So SKU is this number here. That maybe should not be a long. That's my argument. And you want to dissect the SKU into different parts later. In this case, you better treat SKU as a string. So how can you tell Spark which schema you would like your data frame to have? Reading data with schemas. In this section, we explore how to force or to hint to Spark to adopt a certain schema for reading in data. Good to know is that while we're using schemas for reading CSV files in this section, you can use the same process for other file formats as well, so not only CSVs. We could do it with Parquets, with JSON files. Let's pick up where we left and modify SKU to be a string. You can find out more about the schema command in the documentation. Here is a link. Let's pass the schema as a string in the so-called data definition language, and here SKU should be a string. So we need to define the schema in the data definition language, and the way to do this is you could say schema equals SKU as a string, store ID as a double, year as a double, what else? Month as a double. We have way as a string. distance as double. We have distance unit, so kilometers, miles, and so on as a string. We have bundle size as a double. And now let me show you how to read in the CSV using the schema. You could say routes equals spark.read. And now the schema, you just say schema, then you pass the string in data definition language, schema.csv. We need the file path, so /file store /tables /routes preview.csv, and you also want Spark to pass the header correctly. Then display it, display routes. Visually, there's no difference, but the difference we would see in the schema. So let's figure that out. Yep, SKU is now string. And the rest has also been parsed correctly. When you look at the schema, you notice a couple more details that we should sort out. For example, year and month should most certainly be integer variables. Let's write a schema to represent these ideas. So I spare you the details of writing this out again, but here you see I've made a few changes. I put store ID as an integer, year as an integer, month as an integer, and so on and so forth. Let's do it. Let's execute this cell and see if we now get the good schema. Not so good. Why are there these null values in the columns we wanted to parse as integers? It seemed obvious, right? You can just parse 2017 as an integer. It doesn't need to be a float. Let's again show the first couple of lines of routes preview.csv, and here you see it. I mean, in the raw CSV file, there are like these points here. So this looks like a float variable. In the first line, you can see that year is defined as 2017.0, although you told Spark exactly what the schema should be for year. Yeah, we said here, year integer. Make it an integer. Spark cannot honor your request and responds with setting a null value. This is because when using a schema on reading in data, Spark knows no way of interpreting 2017.0 and all other data included in this column as integer. So Spark says, yeah, I hear you, but I'm not going to do this because I don't know what to do. I am just reading 2017.0 and that's all I know, and I don't know how to interpret this as an integer. I don't think this is what you expected and what I expected. So without digging in further, the lesson here is, in practice, when you read in data from a file, you should make sure that the data types in the file match what you expect. I would not have expected Ethan to send me a year as a floating point number. To ensure a well-working big data processing system in production, it may make sense to be more stricter on which data you let into your system and automate that check. So what I'm saying is in a production system, before you read in data, you do a check. Does this data match my expectations? In this case, with the file that Ethan sent, I would say, no, I didn't expect that. Year should be an integer, but you give me float. I'm not dealing with that. Schemas also go beyond data types. Maybe you expect a certain column to be present in the data, and if you want to check that this is the case, then you should have a look at the enforce schema parameter. Because by default, enforce schema is set to true, and this means that Spark will adopt the column names of the schema. It will just use what's in the schema and not check them against the column names which are available in the CSV file. So the column names here, SKU, store ID, and so on and so forth. Let's switch the column name store ID in the schema. So this schema here, the second one is store ID. Let's switch that for store name and leave enforce schema at its default value, which is true. But I spelled it out here. It's the default, but I spelled it out here so you know it's exactly what's going on. And when I execute this, then I see that the second column is store name, even though in the CSV file is called store ID. You see that although header is set to true, which is take the header from the CSV file, which literally says store ID and not store name, Spark simply adopts the column names you hand it in the schema. Those ones here. But what if we expect the second column to be store name and want to avoid reading in bad data into the store name column? Good question. What do? We want the second column to be store name. And we don't want it to be store ID. And we want that Spark helps us figure that out and then say, nope, this is not the data that I'm looking for. Then we should set enforce schema to false. This is exactly the same code that I have here, but I set enforce schema to false. Let's see what happened. Spark throws an error. File read exception, error while reading file, caused by illegal argument exception. CSV header does not conform to the schema. So now Spark is working. Now Spark is checking what's the CSV file looking like and what's the schema that I expect. And we set enforce schema to false, and that means that Spark is then checking whether they're the same, and if not, Spark is gonna refuse to read the file. This is great. It may be better to fail than to read in bad data. Finally, there's another way of defining a schema for reading in data, which you should be familiar with by now. Remember, we had this already in the hands-on session where we used the struct type, the struct field, and you can use the same way to define a schema here for reading in a CSV file. I did this for you. It's a lot of typing. But when you execute it, you will also see the routes table. And it just read them beautifully, and it all worked. And here it's the same way that I define the schema and data definition language. I use this one here. I say schema, take the content of the schema variable. I use it the same with the struct type. So schema takes in the schema variable, and the schema variable includes the whole struct type and struct field thing.